Alright, so now let's talk about Pascal's triangle. The purpose of Pascal's triangle is to multiply out a binomial raised to an exponent quickly and efficiently. So let's say we have something like x plus 2 squared, right? That's pretty easy to multiply out. You just make that little box, x plus 2 here, x plus 2, then you multiply in the boxes. Pretty easy stuff. You don't really need Pascal's triangle for this. But let's say you had something like x plus 2 cubed, or x plus 2 to the 4th. Or maybe you have x plus 2 to the 15th. Now, you don't want to just sit down and just make hundreds of these little boxes to figure out what x plus 2 to the 15th is. What you can use is you can use Pascal's triangle to kind of take a shortcut, so you don't have to multiply every single one out individually. That would be awful, right? So, while Pascal's triangle just kind of looks like some random numbers organized in a triangle, it'll all make sense soon. Okay, so we start off with 1, with our first row. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. And it continues, it just keeps going, keeps going. I'll just stop there, because I feel like that would just be too many, and I'll just keep going and rambling, and we'll just stop at the 1, 2, 3, 4, 5, 6, the 6th row, right? So, it's a triangle, right? Pascal's triangle. It should make sense that it's organized in a triangle. But what do these random numbers mean? And I should mention that I didn't memorize Pascal's triangle. I just used this cool little trick to figure out what is in the next row, right? So we start off with 1. Pretty self-explanatory. Then we move on to 1, 2, 1. Then, you see what we do is we add these two numbers to get our middle numbers. 1 will always be the first and the last number in each row. And then we just keep adding these up. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Same with this row, and same with this row. Right? Just keep adding them and adding them. And that's what Pascal's triangle is. But now I'm going to teach you how to excuse me, how to use it, right? It looks like a bunch of random numbers now. So, let's start off with something easy like x plus 2 cubed, because that's pretty easy to figure out without Pascal's triangle, but it's still much quicker with Pascal's triangle. So, the first thing we're going to do is we're going to have our x cubed. X cubed, and then these numbers are going to be the coefficients. The coefficients are the numbers in front of our x cubed, or our any other thing. It's just going to be our coefficient. I'll make that 1, like that. And then, we're going to have our 2 to the 0th power. So, essentially, with each one of these pieces, we want our powers to add up to 3, because we're cubing it. So, the first part, our first term will be to the 3rd power, and our second term will be to the 0th power. And then this number, this exponent, decreases as it moves along here, and this exponent with the 2 will increase as it goes this way, right? So then our next coefficient is, so I should mention, we're using this row because this is the 3rd row, and since we're cubing it, 3rd row, cube, everything makes sense here. Now, our second coefficient will be 3. So 3, and then since we're going to subtract 1 from our x's exponent, it's going to be x squared, and then 2 is going to be 2 to the 1st. Now the next term, our coefficient will be 3. 3 to the x to the 1st power, and then 2 squared. And then our final coefficient is 1. We have x to the 0 power, which is really just 1. And then we have 2 cubed. So, now we can kind of simplify here. This will just be x cubed, because 1 times 2 to the 0 power is just 1. Then 2 to the 1st power times 3 is 6. 6x cubed plus 2 squared is 4, 4 times 3 is 12, 12x to the first. We don't need to include first powers. And then we have 2 cubed is just 8. So this is our final answer. But now I picked this one because this binomial is pretty easy to multiply without Pascal's triangle. So we can double check it, right? So what we're going to do is we're going to use the box method that I mentioned before. X plus 2, x squared, 2x, 2x, 4. If you're not sure what the box method is, you basically just multiply across and down. So 2 times x is 2x, 2 times 2 is 4, x times x is x squared, 2 times x is 2x, and you just get all these numbers. So we end up getting x squared plus 4x plus 4, because I added 2x and 2x to get 4x. Now, since this is cubed, we're going to have to multiply this number by x plus 2 again. So x squared plus 4x plus 4 times x plus 2, x cubed, 2x squared, 4x squared, 8x, 4x, 8. Now combine like terms, 3x squared, 2 plus 4 is 6x squared, plus 8 plus 4 is 12x plus 8. And would you looky here, these answers are the same. So now we've proven that Pascal's triangle works. I should also mention that if our binomial is something like x minus 2 cubed, our first term would be positive, so x cubed would be positive, and then from then on, the signs would alternate. So our 6x cubed would be negative, this would be positive, alternating, and then our 8 would be negative. That's how Pascal's triangle works.